we're live on YouTube. We are live on YouTube.
Live on YouTube.
All right. I'm going to hand you your scepter. You're live there. I'm going to post and monitor downstairs, and then I'll be back up.
Okay.
When I'm up. Have a good show. Break a leg.
Thank you. Okay, let's go live on here. All right. I feel like all my favorite markers have ended up in my little travel pouch. All right, guys, it is a good day to do math. Woohoo! So, let's get into it. Let's see. All right, let's see. Math Thursday, Lucas. All right, guys, let's see what we can do with this. I know a lot of people are on spring break this week. At least around here. I don't know. It's always interesting to me who's on spring break when, because we always get the last 2 weeks of March off. But then I know there's a lot of schools that line it up with Easter, which that makes for a long stretch between New Year's and Easter. That's a long time. Those of you who are still slogging through, getting ready for Easter, man. It's a long wait to have a break. So Godspeed. All right, so how are we going to solve this one? Anybody have a solution? Put it in the comments. So we would normally follow PEMDAS, but we've got that X there, so we need to, yeah, so we're gonna need to use the distribution property, right? Okay. That's okay. Giselle, is that your name? Giselle, I think. It's okay, you're in the right place. Okay. So the first thing we're going to do on this is we are going to distribute the 2. Okay. You're going to distribute the 2. So that means that I'm going to multiply. This means I have 2 groups of 3x minus 1. So if I have 2 groups of 3x minus 1, I'm going to multiply everything in here by 2. That's called the distributive property. So 2 times 3x, if I have 2 groups of 3x, I have 6 x's. And I have 2 negative 1s, which means it's minus 2. Now, once I've distributed this, the only reason that parentheses is there is because that's 2 of this whole group. So once I've distributed that 2, I can drop the parentheses. And then I've got plus 4 equals negative 10. So now from here, I could do -4 from both sides. I could add 2 to both sides, or I can just go ahead and combine these. Usually you try to simplify each side first, then you start solving. So simplifying means I'm going to get everything kind of like lumped together. So we can do that. So we have 6x and we have -2 plus 4. So we get 6x plus 2 equals -10. So we want to get that 6x by itself. So I'm going to take away that 2, but I can't just do it on that side. I have to do it on both sides. So now I have 6x equals -12. And then if I divide both sides by 6, I get x equals -2. And I kind of ran out of room there, but that's what we get. X equals -2. Because -12 divided by 6 is -2. Okay. All right. Okay. All right, so let's just kind of kicking us off here. So welcome to MATHursday. We're going to be talking about, mainly we focus about like pre-algebra through algebra 2, trig, a little bit of pre-calc. But if you're looking for calculus help, it's not really something that I help with much on this channel. However, if you have a question, put it into the chat because we've got a great community here, and everybody is usually very, very willing to help with that. So I can do, factoring quadratics, teaching exponents with negative. Do you mean teaching exponent, like negative exponents? Or like negatives with exponents? Oh, guys, we can do polynomials the whole time. 4 times 10 to, oh, so like, so Johnny G, it looks like you're talking about scientific notation. Okay, so negative exponents and scientific notation. So they are related. So scientific notation is something like 1.3 times 10 to the third. Okay, so we use scientific notation to talk about or to work with really big or really small numbers. So 1.3 times 10 to the third is really just a way. So this first part here, this number here needs to be between 1 and like 9.9, right? So it needs to be greater than 1, less than 10. And then this power to the 10 is to show you like how the decimal moves. So when this exponent is a positive decimal, when this exponent is a positive number, we move the decimal to the right that many spaces. So if I'm looking at this, I would have 1.3 and then I move it to the right because this is positive, and I move it 3 spaces because that's a 3. So I'm going to go 1, 2, 3, and then I fill in with zeros. Okay, so 1.3 times 10 to the third is actually 1,300. Okay, so with a negative exponent, what a negative exponent does is it's going to, if you have, well, let's say 1.3 times 10 to the -3. Okay, so the negative exponent drops this base down to the denominator. Okay, so this is actually 1 over 10 to the third. Okay, so in this case, since this is negative, my decimal now is going to move to the left 3 spots. So I'm going to actually set it up over here because I know I'm going that way. So I'm going to go 1, 2, 3. We go there. I'm going to fill in with the zeros. Okay, so this is actually going to be 1.3 times 10 to the -3rd is 0.0013. Okay, so this is a lot of, this is mostly, you'll learn this in middle school, but you will also learn this a lot when you're getting into chemistry. Chemistry, you use it a lot. And so this is something that you will see a lot. Okay, now if you have something like, if you're multiplying these things together, right? So you have 1.2 times 10 to the 4th times, we'll use parentheses like this, times 3.4 times 10 to the third. Okay, this is all multiplication. Okay, so this is all multiplication. And so what I can do with multiplication is it doesn't matter what order I do the multiplication in. Okay, so I've got 1.2, and what I'm going to do is I'm going to multiply 1.2 times 3.4. I'm going to do that over here. 1.2 times 3.4. Then, and I'm leaving these with an x just because that's kind of how you usually show scientific notation. Then I'm going to take the 10 to the fourth and the 10 to the third, and I'm going to keep those over here. 10 to the fourth times 10 to the third. So it's, you can kind of think of it as like combining like terms. It's not combining like terms, I know, but it's more like multiplying kind of like similar things. Okay, so I've got 1.2 times 3.4, 1.2 times 3.4, which is 4.08. Okay, now it depends on if you're doing sig figs or not, if you need to pay attention to that. Okay, and then it's times 10 to the fourth times 10 to the third. I'm going to add those exponents together. So that becomes 10 to the seventh. Okay. Now 4.08 times 10 to the seventh is a lot easier to write out than 408000000, right? It would be 408 and 5 more zeros. That's what you would be writing out, right? But so this is how you would multiply that scientific notation together, okay? So negative exponents, like I said, it just drops it down into the bottom. So something like, so 10 to the negative 2 equals 1 over 10 squared, which is 1 over 100. That's why it makes it go into a smaller number, is because you're actually multiplying by this fraction. Okay, so that works also with like x to the negative third. That's going to be 1 over x to the third. Okay, now what if you have a negative exponent on the bottom? Well, it's just going to flip it right over. So if I had 1 over a to the negative 2, that's going to be a squared. It just pops it back up. So negative exponents really just flip it up and down. Okay. Yeah, so a lot of times you'll see a lot of this I would say it's pretty solidly in 8th grade, but you also revisit it, and you especially revisit a lot of the scientific notation in chemistry, and more advanced like science stuff and things like that. Okay, so we've got, let's see. Do you add zeros to every scientific notation or no? If you need to move the decimal, you would add zeros, yeah. Okay, so I'm seeing a lot of questions about limits, and that's a little bit beyond of what we do here. So we're mainly in Algebra 2, trig, those types of things. And Algebra 1 and pre-algebra, of course. But if you have a question about limits, go ahead and put them into the chat, because somebody may be able to help you out with that. Okay? All right. So factoring polynomials, I also have a ton of videos on all my channels about factoring polynomials, but we can do one really quick because I love them so much. Okay, so factoring polynomials, why don't we start with, why don't we just go ahead and jump right in? So what is factoring when you're dealing with polynomials, right? So when you are factoring something, like if I were factoring 36, okay? If I were factoring 36, I would be listing out all the factors of 36, right? So that could be 3 and 12, that could be 4 and 9, that could be 1 and 36, 2 and 18, all of those things, right? So factoring means that you are writing something as a multiplication problem. Okay, so writing 36, so factoring 36 could be rewriting it as 4 times 9. This can be really helpful in a lot of different ways. A lot of times, when you're in a polynomial, okay, if we're factoring a polynomial like 4x squared minus 15x plus 9. Okay. 4x squared minus 15x plus 9. So what we want to do is we want to rewrite this in a way that we're multiplying two things together. Okay? So since this first coefficient is 4, it's not 1, what I always teach and what I always learn, what works the best for me, but there's lots of different ways to figure out factoring, is you do 4 times 9. This is called the AC method, and we get 36, right? 36. Okay, so now we need to look for two factors of 36 that also add to negative 15. Okay, so two things that multiply to make positive 36 and add to make negative 15. So if this one is positive, that means that the signs are going to be the same. This one here means that they are both negative. So we need two negative numbers that multiply to 36 and add to negative 15. Okay, all right, so we've got a lot of good guesses. Okay, so I know we were looking at 4 and 9 up here, but negative 4 plus negative 9 doesn't equal negative 15. So what we're looking at is actually we have negative 12 and negative 3. Those both multiply to 36 and they add to negative 15. Okay, so now we are going to rewrite negative 15x. We're going to rewrite it using our two factors. Okay, this is the AC method. Yep. Okay, so I'm going to rewrite negative 15x is the same thing as negative 12x minus 3x. Okay, so I split that middle term into these two factors. Okay, so now I've got 4x squared, and I've got plus 9. Okay, so here's what I did, right? Let's do a recap, right? AC method. So I do 4 times 9, which is 36. And I need to find two factors of 36 that add to negative 15. So that would be negative 12 and negative 3, because if I multiply two negatives together, it makes a positive. If I add them, it makes a negative. So then I take this negative 12 and negative 3, and I split that middle term. Okay. So I split that middle term, and now this is factoring by grouping, which is where we do, I'm going to find the GCF in each of these. The GCF is the greatest common factor. So what's something that both of these terms are divisible by? So I'm looking just at this first half. So 4x squared minus 12x. Okay. The GCF for that is 4x. All right, so we got 4x here. If we take that out, what's left over? X minus 3. Okay. I'm going to take out the GCF of negative 3x plus 9. Okay. So negative 3x plus 9. So what I'm going to factor out, since this first term is negative, I'm going to factor that negative out. So I'm going to factor out a negative 3, and what's left behind is x minus 3. So a couple of things that I'm looking for. These two, like in the parentheses, have to be the same. Okay, they have to be the same because that becomes one of your factors for this trinomial. Okay, and this one, this 4x minus 3, becomes the rest of it. Okay. So we've got x minus 3 is one of the terms, or one of the factors. The other one is this 4x minus 3. Okay. So if we multiply these together, right, if we just do like foiling, right, we would have, so 4x times x is 4x squared. 4x times negative 3 is negative 12x. Negative 3 times x is negative 3x. -3 times -3 is +9. So then I combine all of those terms. So I have 4x squared minus 15x plus 9, which is what I started with. So, woohoo! We factored it. Okay, we factored that trinomial. Yay! Okay. Oh my gosh, the chat is like catching up.
You have 143 viewers.
Wow. Okay. All right, so a parabola. So BR, parabolas. What do you need from a parabola? So are we graphing? Are we finding the vertex? What are we doing? Okay, Addison, composite figures. Do you mean like finding the area of a composite figure? Okay, so graphing the parabola. Okay. Okay. Okay, so I'll do composite figures, and then BR, I'm going to do a graphing a parabola in just a second. Okay, so composite figures are, I'm just going to start with some simple ones like this, right? Where we've got, if we need to find the area of this shape, right? So if we need to find the area of this shape, and I know that this side is 4, and this is 3, and this whole side is 12, and this side is, I don't know, let's say 5. Okay. So we could divide this in 2 different ways, right? Well, actually, we could divide this in a lot of different ways, but the main 2 are like you could divide it here, right, into those 2 rectangles, or we could divide it here into those 2 rectangles, right? No, it's not drawn to scale. I get it, right? That side is 3, that's whatever, right? It's still going to work, okay, even if it's not drawn to scale. So personally, I prefer this one because it's very straightforward about what the side lengths are, right? So I'm going to go ahead and I'm going to divide it up, and I'm just going to put in a line here. Okay, because with a composite figure, it's made up of these 2 different figures. So all I need to do is find the area of each one and add them together. Okay, and I see a whole lot of people with their guesses in there. Excellent, keep it coming. Okay, so we've got these 2, and you can double check and make sure that it works both ways, right? That the finding the area works both ways. So 3 times 5 is 15 for this little rectangle here. And then right here, 4 times 12 is 48. So then what we would do is we would add these together, and 48 plus 15 gives us a total of 63. Okay. Gold star. Okay. How would you find the line in between the 3 and the 4? So finding this length here. So to find this length here, you've got this part right here. Okay. And what you know is you know that this whole side is 12, which means that this whole side is 12. So if that whole side is 12, but that's 5, then that means that that has to be 7. So this side length would be 7. Okay. And that is another way that you could figure this out, is you could just kind of square this off and then subtract. Sometimes that's a little bit easier. So sometimes that's a little bit easier, but it just depends on the information that you're given. Hi, Miss Loomis. Let's see. Okay, parabola. So let's talk about graphing a parabola. Okay. All right, so when we've got, let's see. All right, so if we've got a function, let's do, 6, that should be fine. Okay, let's do this function. So we'll do f of x is x squared minus 2x minus 6. Okay. Okay, so we're going to talk about graphing a parabola. So this is a quadratic. Okay. So the first thing, one of the first things we want to do is we want to find the, so here we go. So it's a little bit different if you are able to use a graphing calculator or not. If you're able to use a graphing calculator, you plug this in, you check the table, you get all of those values. If you are not able to, okay, then we need to do a little bit more work. So the first thing we want to find, there's a couple of different parts of a parabola that we need to find. So here, I'm just gonna rewrite this over here. F of x equals x squared minus 2x minus 6. Okay, so a parabola, in general, it looks like a U or an N, I guess, right? Like an upside down U. So what it does is, since this first value here, this A value is positive, it's gonna open up like this, okay? So I know it's gonna open up like this, and it's gonna be shaped like a U, and that bottom point of the U is what we call the vertex. So the vertex, to find the vertex, we use negative B over 2a. I'm going to write the negative up here. Negative b over 2a. Okay, that's going to give us our location. That's going to give our x value of our vertex. Okay, so negative b. So b is negative 2. So it's a negative negative 2, which is just 2. And 2 times 1 is 2. So that means it's 1. So what that means is that where x is, or I'm sorry, at the x value of 1, that is where our vertex is going to be. Okay, now what we do now is to find the other coordinate of our vertex, we plug in the 1 for the x. So we find f of 1, which is 1 squared minus 2 times 1 minus 6. So this is going to be 1 minus 2 minus 6, which is going to be negative 7. So our vertex is at the point 1, negative 7. Okay, so we go to 1 and then negative 7, 6. Sorry, I lost my count. 2, 4, 6, 7, right here. Okay. Now a parabola is symmetrical. Okay. So this parabola is actually going to have what's called the axis of symmetry, which is going to be right along here. This whole line. Everything in this parabola is going to be like mirrored. This would be like the line that you could fold it over. Okay, so if you find a point on one side, it's going to have a mirror image on the other side. So you really only need to find a couple of points. Okay, now one of those points that you want to find is the is the y-intercept. The y-intercept, I mean, from like the first time you graph a line, you know what the y-intercept is, right? It's where x equals 0. Right? So we're going to find that. So the y-intercept is where x equals 0. So we want to find f of 0, which is 0 squared minus 2 times 0 minus 6, which means that it's just at negative 6. So our parabola is going to cross at negative 6 right there. Okay. Now remember, it's a mirror, right? So I know that if that point is there, there's going to be a point in the exact opposite spot. Okay, so there's my curve at the bottom. Okay, now what we want to see is like how open is it? Okay, so how open is it? And there's different things like with the A and the B and how they kind of play along and all of that. But what I'm going to do is I'm going to find, let's do like 2 more points, right? So now what I can do is let's do, we got 0. How about let's find negative 1, right? Let's do f of negative 1. So I'm going to plug in negative 1 for my x. So I've got negative 1 squared, which is 1. Negative 2 times negative 1, which is plus 2. and then minus 6. So I've got 3 minus 6, so that's negative 3. So that means when x is negative 1, y is negative 3, so I've got a point there. And remember, it's a mirror image, so it goes over here as well. Okay. And then we could probably find a third point, right? So if we do like f of, I don't know, I guess that's probably enough for the plotting. Okay, so then you can just kind of do your best for graphing it, right? If you're graphing it by hand like this, what your teacher's really going to be looking for is, did you find some extra points? Did you do the axis of symmetry? Is the vertex in the right spot? Is the y-intercept in the right spot? That's what your teacher's really going to be looking for. Can you do all of this generally by hand? So that is graphing a quadratic, graphing a parabola right there. Parabolic function, I guess. Yes.
You had a question from Instagram.
Okay.
What does f of x mean, and is it the same thing as y?
Oh, okay. That is an excellent question. So what does f of x mean, and is it the same thing as y? So f of x, the f stands for function. So here, right, my function is x squared minus 2x minus 6. So f of x is basically like, what is the value of x after you run it through the function? Okay, so f of 1 is negative 7, because when I plug in 1 for x, I get negative 7. Now, when we graph it, yes, the f of x value is just the y value, right? But if you're just working with a function notation, that's really what it is. Okay, so you finally do you just plug in the 1 or whatever that value is for x. Oh my gosh, I get Caroline Ray all the time. I mean, I'll take it, but yeah.
Good thing I had a thing for Caroline Ray.
Yeah, I don't know. It was closer when my hair was longer, but yeah, I'll take it. Okay, let's see. So I think that, how did I get so the y-intercept is where x is 0. So you just plug in 0, but you can also look at, just like in y equals mx plus b, the b is always the y-intercept. This is always the y-intercept. That negative 6 there is always the thank you. This is where the y-intercept is going to be all the time.
You got another question from Instagram.
Okay.
An actual problem.
So this topic is called quadratics, or graphing quadratics, or a parabola. Sorry, I gotta do. So domain and range. So domain and range is something that comes up a lot. Domain is all the possible x values, and range is all the possible y values for a function. So the x values, this function is going to run through all the x values, right? All of these that are shown, because it's going to keep going and there's going to get further and further and further and further apart, they're eventually going to get through every value for x. So my domain for this would be, I guess you could say x is all real numbers. It depends on what kind of notation you're using, right? The range is a little bit different, because the range is all the possible y values. Now, I'm not going to go through all my possible y values here, right? I'm going to only go from negative 7 up, right? So y is greater than or equal to negative 7. That's it. So my range is going to be from negative 7 to infinity, right? And sometimes you'll have teachers who want it to be like a range, right? Like, so you would have infinity. You would have, I forgot that was negative 7. So your range, if you have to write it in like interval notation, it would be negative 7 to infinity. And the domain would be negative infinity to infinity. Just depends on how your teacher wants it. It is negative 7 because that's the range. Negative 6 is your y-intercept. Okay. And this is a trinomial. Okay. What was the question?
It looks like they were just asking, can you do x minus equals minus b plus or minus square root of, like, just basically doing the quadratic again. Like, you just did a quadratic though, right?
I just did factoring. I did not do any solving quadratic using the quadratic formula, so I can do that. Okay, quadratic formula. Whoop, whoop. Oh, okay, so okay, so somebody asked for the vertex form of this, and that is usually a pretty good follow-up. So the vertex form of a quadratic like this, where you've got x squared minus 2x minus 6, and then we can actually use this one for quadratic formula too. So writing this in vertex form, which vertex form is just a different form of writing. This is a standard form of a quadratic where you have like the ax squared plus bx plus c. The vertex form is where you have f of x equals a times x minus h squared plus k. And the h and the k are your vertex. So in this case, our vertex was 1, negative 7. Right, so our vertex was at 1, negative 7, right? Our a is 1, and so our vertex form would be f of x equals x minus 1 squared minus 7. So that would be my vertex form. And then if I needed to solve or if I needed to write this in standard form, I would FOIL this out, right? I would do x minus 1 times x minus 1 and then combine the like terms. Okay. So solving quadratics. So this is, it's all coming together, guys. It's all coming together. Okay. So solving this. So when you are asked to solve a quadratic, or solve this problem, right? What you're really looking for is you are looking for these spots where it crosses the x-axis. Okay, so those are your roots, those are your solutions, those are your zeros, they're all the same thing. Okay, what you're looking for, so to solve, so solving means you're finding the x values so y equals 0, okay? So solving is when y equals 0. So if you are given a quadratic like this, right, where you have f of x equals x squared minus 2x minus 6, okay, and you are asked to solve it. What you are asked to do is you are being asked to find where f of x, or I'm sorry, where the y is 0, so f of x is 0, not f of 0, but f of x is 0. X squared minus 2x minus 6. Okay, so we are going to solve this. So you can solve this in a few different ways. So solving quadratics, you can try factoring it. Okay, this one here is not factorable. Okay, and the reason I know that is because there are not 2 factors of 6 that I could add together to make negative 2, right? I can't do 6 and 1. I can't do 3 and 2. So I can't factor it, which we just did some factoring before. Can't factor it, so I move on to my other 2 options. My other 2 options are completing the square, which I love, or quadratic formula, okay? So quadratic formula is kind of the default one. Like, you check to see if you can factor it. If you can't, do the quadratic formula. Okay? So All right, so let's do quadratic formula first. And then I'll show you completing the square. Okay, I'm going to put this off to the side for now. Okay. Okay, so the quadratic formula, everybody pull that song out from the back of your mind. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, there we go. Okay, so our a is 1, our b is negative 2, and our c is negative 6. Okay, so we just plug in the values and we solve. Okay, so we have x equals negative negative 2, so that's positive 2, plus or minus the square root of negative 2 squared minus 4 times 1 times negative 6 all over 2a, which is just 2. Okay, so negative 2, oh wait, I'm going to write this first. 2 plus or minus square root of negative 2 squared is 4. Negative 4 times 1 times negative 6 is plus 24 over 2. Oh, this gets, oh my God, this is tying up so many questions. Simplifying radicals, all these things. This is not long division. This is a quadratic formula. Okay. All right. So now I'm going to simplify this even more. And I get I get 2 plus or minus the square root of 28 over 2. Now, square root of 28, I can simplify. Okay. I can simplify it because if I think about the factors of 28, 4 and 7, I can take the square root of 4. Right? So I can take the square root of 4. So this becomes 2 plus or minus square root of 4 times 7. So square root of 28 simplifies down to 2 root 7 over 2. I've got 2, 2, and 2. Those all simplify. They all reduce down. And I get 1 plus or minus root 7. And those are my two values. Ta-da! Okay. This is not necessarily algebra 1. This is a little bit more like algebra 2. But yeah, so you may learn these in algebra 1, but you will definitely learn them in algebra 2. Okay. So the x values, so my x solutions, so my roots are, so this would be, so my solutions, if I write them out as a set, it would be 1 minus root 7 and 1 plus root 7. So that is where my two values would be. Right here. So 1 minus root 7 and 1 plus root 7. Now remember, I just kind of eyeballed these, so I'm not saying that's perfect. Okay? But 1 minus root 7 and 1 plus root 7. That's where my zeros would be. Okay? So I mentioned that there's another way to solve this, which is completing the square, which I really enjoy completing the square, but it has to be, I'm not going to do completing the square on every single problem because it's a nightmare. So let's go back to our original function, right? So I'm trying to solve, I've got 0 equals x squared minus 2x minus 6. Okay? So what I can do is I can look at the, on this one in particular, I probably would have done completing the square because quadratic formula can get really confusing. So what I'm gonna do though is I'm gonna flip this so the zero's over on that side. Just preference. Okay, so the reason I would look at this and I would say, oh, I can complete the square on this one, is that completing the square is if you have something like, okay, completing the square. If we have something along the lines of like x plus 3 squared, okay? So that means if I have x plus 3, well, this is x plus 3 times x plus 3, right? So I have x plus 3 on this side. I'm just going to kind of set it up like an array, right? Or like a little box thing. Okay, and then I've got x plus 3 on this side. Okay. So x times x is x squared. Right? X times 3 is 3x. X times 3 is 3x. And then over here would be 9, right? So you have made a square because it's the same lengths on all the sides, right? Because x plus 3 times x plus 3, those are the same things, okay? So when I figure this out, I have x squared plus 6x plus 9, okay? Now, if I had something like, if I had an equation that I was solving and I said, oh, x squared plus 6x plus 5 equals 0. And I look at this and I go, oh man, x squared plus 6x, if this were a plus 9, it would be a perfect square, right? But it's not, so guess I can't do it. Yes, you can. First of all, you could factor this. But also, you could look at that and you could say, okay, well, I know x squared plus 6x plus 9 is a perfect square. Okay, so what I can do is by completing the square, I can literally just like force it to be a square. So I'm going to force it to be a square by just adding 4 to both sides. If I add 4, now I have x squared plus 6x plus 9 equals 4. It is a perfect square. That is what it means by like completing the square, okay? Yeah, this one you could factor, but it was just showing how to complete the square. Okay, so let's go back. Oh my God, I basically erased that whole thing. Okay, so let's go back to this one that we were working on. Okay, x squared minus 2x minus 6 equals 0. So I looked to see, could I make this a perfect square? And this one I can, because this middle term, this b, is an even number. If it were not an even number, I'm not completing the square. I'll just go to quadratic formula. If I can't factor it and this is not an even number, done. I'm not completing the square. This needs to be 1. This needs to be an even number. Beyond that, like completing the square, I don't find the use for it, but that's all right. So half of this is -1, right? So if we think back to this here, right, that middle term was a 6, half of it was 3. So that's my square. That's like my part of my binomial, okay? So then I knew that this was needed to be a 9 because half of 6 is 3. 3 squared is 9, okay? Half of this is -1. -1 squared is 1. So I need this to be a 1. So to complete the square, I'm going to add 7. Why am I adding 7? To make this into 1. But I've got to do it on both sides. So if I do that, I've got x squared minus 2x plus 1 equals 7. Now, x squared minus 2x plus 1 is the same thing as x minus 1 squared. Okay, I forced it to be a perfect square. I completed the square so that I could do this. And once I have it set up like this, now I can just do square root of both sides. So I'm going to do square root. So the square root of anything squared is itself. So I've got x minus 1 equals positive or negative root 7. And then I add 1. So I have x equals 1 plus or minus root 7, which looks an awful lot like what we got from the quadratic formula right there. Ta-da! Okay. So the AC method, totally valiant. It works if it is factorable. Not all quadratics are factorable. So I can't factor this one. There are not two factors that multiply to -6 and add to -2. I can't do it. Okay? So I have to either complete the square or use quadratic formula. Okay? So AC method factoring is great. It's wonderful. That's always the first thing that I look for. But a lot of times it doesn't work out. Okay? All right, good. Good, I'm glad so many of you are learning this right now. Square root of 54, so simplifying radicals. So simplifying radicals, you're gonna look for the factors. Man, today is all about factoring.
What do you think contributes to that?
There's a lot of different factors. Get it? Hey. Okay. So simplifying a radical, kind of like what we did with that square root of 28, right? So the square root of 54, we think about the factors of 54. So when you've got the factors of 54, so if we think about 54, well, the first one that comes to mind is 6 and 9, right? Or 9 and 6. So I can rewrite this as the square root of 9 times 6, right? 54 is 9 times 6. I can do that. So now the only way to come out from under the radical sign is to get the square root taken. So the square root of 9 is 3. It would be plus or minus, sure. Okay, plus or minus 3. I can't take the square root of 6, so that one's going to stay as root 6. Okay. So that's how you simplify radicals, is you look at the factors and look at the, like any factors that are perfect squares. That's what you're going to be looking for with those. Okay. All right. Finding the area of a sector in a circle. Okay, so I saw some arc length stuff too. So oh, my neck hurts. Okay. What is happening? Okay. So when you're talking about finding the area of a sector, I didn't see what the question was. Hold on, guys. Sorry, I gotta go back up. Oops.
Scroll.
Okay, sorry guys. There's a lot of questions in here, but I do have a lot of other videos and things with a lot of topics on there. Where did the... Okay, I lost the question about the sector, the area of the sector, and and the arc length and all of that. I lost those, but those are really straightforward formulas that you can use. And you know, when you're finding the area of a sector, when you're finding the area of a sector, like a little portion of a circle, what you have to keep in mind is that you're really just looking for, it's basically like you're finding a fraction of the area of the circle. So the area of an entire circle, the area of a whole circle is pi r squared, right? So if this is your radius, right, and you're just trying to find this area here, okay, the whole circle, if you're talking about degrees, is 360, right? So the area of a whole circle is pi r squared, okay? So when you're looking for the area of a sector, if you have this degrees, right? Let's say that that is, I don't know, 70 degrees, right? So your angle is 70 degrees. So that would be 70 out of 360, because it's just like a fraction, right? So if you've got 70 degrees out of the 360 degrees, right? It's that theta, it's that angle measurement out of 360, it's a fraction, times the area. Just like if you said, oh, what's the area of this half circle? You would do 1/2 times pi r squared. What's the area of this quarter of a circle? You would do 1/4 pi r squared. It's the same idea, it's just that you can divide the circle up into 360 degrees. Just kind of an easy little way to divide that up into like a fraction, okay? Working with radians is really nice too, but the problem is that you usually don't learn radians until a bit later in school, like Algebra 2. So you may or may not know what the radians are when you first learn this in geometry. Shaggy19, you just missed a whole big thing about quadratic formula. So you can, it's on, if you go over to YouTube, you can rewind, and I just worked out a whole big problem on quadratic formula. So you can check it out over there, okay? Okay, your fave, I just did factoring not long ago, so you can hop over to YouTube and rewind it and rewatch that part on factoring. Maddie, law of sines. I can do law of sines. We can do law of sines. That's totally fine. Okay. Let's see. So the law of sines is how you can use trigonometry to solve a triangle. Okay, to solve any triangle, really. It doesn't have to just be a right triangle. So when you first learn trigonometry, you are typically just talking about right triangle trig. But when you get into the law of sines, you can start learning about how to use it for other triangles as well. Not the triangle I wanted to draw. Okay. All right, I'll do that. Not drawn to scale. Just have to clarify that. Okay, so let's call this A, B, C. When you start dealing with, when you're starting to work with triangles with trig, where you've got like angles and side lengths, you start using uppercase letters for angles and lowercase letters for sides. So this side that's across from angle B is going to be side B, a little b. This one that's across from angle A is going to be little a, and then this one is little c. Okay, so because the law of sines is dealing with angles and side lengths, you have to make sure you're keeping track of like if it's an angle or a side length. So the law of sines states that the side lengths and the angles that are across from there are related in a specific ratio, and all of the angles to the side lengths are the same ratio within a triangle. So what that means is that, for example, the ratio between side A and sine A is the same as the ratio between the side length B and sine B. And it's the same as the side length C and sine C. Okay, so that is the law of sines. So if you are given any bit of information about these triangles and the sides and all of that, you can figure out the other stuff. Okay, so if you are given, now there is such a thing called the ambiguous case, which I want to kind of stay away from because it can get a little bit confusing and tricky. Sorry. So let's see, I want to do, I'm doing angle, side, angle. Come on. Help me out here. Come on. I could probably just make it up, but I just want it to be nice. And easy. Oh, well, I guess I can do this. Okay. So let's say that we're given the information. So usually when you're dealing with this, you're being asked to like solve a triangle. Solving a triangle means you're finding all the side lengths and all the angle values. Okay. So if I'm given this information, all right, so let's say, I hate how crooked that is. So the measurement of angle A is 45 degrees. The measurement of angle B is 70 degrees. And then side B is 15. Okay? So I've got 3 bits of information here, right? So I know that angle A is 45 degrees. I know that angle B is 70 degrees. And I also know that side length B is 15. So I'm going to fill in what I know. And now I'm going to solve for what I don't know. So here I've got one complete ratio, right? I've got measurement of angle B and I've got side length B. So then I can use the measurement of angle A to figure out the side length of A. Now, based on this, I already know what angle C is, right? Because all angles in a triangle should add up to 180. So if I do 180 minus 45 minus 70, I get that angle C is 65 degrees. Okay, because again, all triangles are going to add up to 180. The angles in a triangle are going to add up to 180. So 45, 70, and 65, that's what equals 180. Okay, but so I need to find side A and side C, and I'm going to use my law of sines. So I'm going to plug in what I know, solve for what I don't know. Okay, so I've got, let's see, I've got side B, which is 15, over sine of 70. So side B over sine angle B equals side length A over sine 45. Okay. Now what I'm going to do here is I'm not going to start, this is law of sines. I'm not going to start like sine 45, sine 70. It's going to give me a crazy decimal. I don't want to work with that right now. I just want to first get it all in the right point for me to have a by itself. So I'm going to cross multiply, just solving a proportion, right? So I've got sine 70 times a equals 15 sine 45. So then I'm going to divide both sides by sine 70, and I get that side length A equals 15 sine 45 over sine 70. Now that I'm going to type into my calculator, and I'm going to make sure that I'm in degrees mode. What?
Is degrees mode, it only returns the answer C's. Because C's get degrees, baby.
Oh my God. That was terrible. Terrible. Okay, so I've got 15 sine 45 divided by sine 70. Got 11.29. Okay. So that's what we get for our side length A. So side A is, we'll call it 11.3. Okay. Now, since this one is rounded, I'm not actually going to use that one to calculate. I'm going to go back to using my 15 and sine 70. So then I make sure that I get a really accurate, answer. Okay, so I'm going to set this up in a similar way. So I'm just going to kind of move that up a bit. Okay. I guess I'll write this one in black. Okay. So I'm going to do, okay. So 15 over sine 70 equals, and the side that we don't have is C, so we need C over sine 65. Okay. I'm going to cross multiply again. So C times sine 70 equals 15 sine 65. And then I'm going to divide both sides by sine 70, so I get C equals 15 sine 65 divided by sine 70. Very similar, but just a little different, right? So I get that side length C is approximately, let's see, we got 15 sine 65 divided by sine 70. 14.46, so it's about 14.5. So that is our triangle all solved using law of sines. Law of sines is really fun. I'm using my numworks right here, Evie. Okay, good, Maddie. So law of sines, you can use it for, you can't really do this without using sine, other than just finding the, like the third angle, you could do that. But it's difficult to do without trig, because trig is how you're connecting those angles and those and the side length measurements. So that is what really joins those together. So since this is not a right triangle, you can't just find the angles and the side lengths. Okay, guys. So there are so many. So if you are having trouble with any questions that we didn't get to today, go ahead and check out my video library. There's so many videos up there, polynomials, quadratics, graphing, all sorts of things. Go back and I will be back next Thursday for MATHursday every Thursday. And if you need, or if you want to look into some one-on-one or small group tutoring, like maybe there's a group of you that are in a class together and you want to just have some virtual tutoring, let me know. Click the link and do the stuff. And have a great night.